Example 9 on page 124. A uniform rod AB of length 4 meters and mass 12 kg is resting in a horizontal position on supports at C and D, with AC being equals to DB, and each one of them is equals to 0.5. AC equals to DB 0.5 meters. When a particle of mass mkg is placed on a rod at point B, the rod is on the point of turning about D. When a particle of mass mkg is placed on a rod at point B, the rod is on the point of turning about D. Find the value of m. It is important to note that it's a uniform rod, and the mass of the rods will always act on the rod right at the middle. So if the whole rod is 4 meters, then from here to where the mass of the rod is being experienced, it has to be 2 meters. And because we have 0.5 meters here, then we have 1.5 meters here. And likewise, this is 1.5 meters. This question is special, very special indeed, because you can see when the mass of kg is placed on point B facing downwards, the rod is at the point of turning about D. Very interesting. When the rod is at the point of turning, then you will just realize that the rod is almost moving upwards at point A. What does that mean? It is just about to turn, meaning that the rod does not exert any force on point C because it is just about to turn. And if it does not exert any force on the fulcrum C, then the reaction is equals to the force that is exerted downwards. And because it is at the turning point, then RC will always be 0 when the rod is at the verge of turning about D. So there is very little contact between the rod and the point C here. It doesn't exert any force downwards, and likewise, it doesn't. Point C does not exert any force upwards. So that is why we must always remember in this situation, then RC, or the reaction of C, is always going to be equals to 0. Now, at that point, let us now take the moments about D. Moments about D. What are the moments about D? Of course, mg times 0.5, you can see the moment due to mg about D is 0.5 mg, of course clockwise, and this must be equals to the moment about D due to the mass of the rod, which is anti-clockwise. And because it is still at equilibrium, it's just that it is at the verge of turning, therefore, this is going to be equals to 12g times 1.5 because it is now anti-clockwise. What is m? This is clockwise and this is anti-clockwise. So basically what you're having is 0.5 mg equals to 12 times 1.5, which is 18g. So what is m? The value of m, we just have to divide by 0.5g on both sides, 0.5g. And therefore, we have m is equals to 36. and this 36 is our value of m. Basically, the most important point or anything, the most important thing to note in this question is how the reaction at C is at 0, even when we are not going to use C as the turning point. We are going to use D, but because it is at the verge of turning, then there is no force downwards, and likewise, there is no force upwards. All right?